The students of ninth standard, now we are going to study about periodic classification of elements, which is unit 12 in our science book, periodic classification of elements. So from the name itself you have to understand periodic classification, classifying, regulate the elements in certain order, the regulation of elements in certain order. So we are going to study one by one now. See, in the introduction part, see, you are having book, you take page number 138, take page number 138 and listen. See, we live in the world of substances with a great diversity. Substances are formed by the combination of various elements. So whatever we see in and around us are called matter or substances. Matter or substances. For example, in our body, fat, protein, vitamins are there. So the fat proteins are formed by the combination of various elements like hydrogen, oxygen, sulfur, like that. Also in the outside we are seeing so many elements. You take milk, sour milk, or salt, and calcium phosphate, calcium sulfate, whatever we see, all the things are made up of by the combination of various elements. So all the elements are unique in their nature and property. If you take hydrogen has a peculiar property, and iron has peculiar property. Its atomic weight, atomic mass, radii, everything are different to one another. So to categorize these elements according to their properties, scientists started to look for a way. So the chemists find a way how to arrange these elements. They used a certain order. See, in 1800, there were only 31 elements. At the time, only 31 elements were known. After that, in 1865, number becomes 63. Now we are having 118 elements. So if you are asked question, how many elements are present nowadays? 118 elements have been discovered. As different elements were being discovered, scientists gathered more and more information about the properties of these elements. So scientists gathered more information, their atomic number, mass number, atomic radii, ionization energy. There are a lot of properties. So those properties were gathered by the scientists to arrange the elements in certain order. So they found it difficult to organize all that was known about elements. So they started looking for some pattern in their properties on the basis of which they would study such a large number of elements with ease. Let us discuss the concept of classification of elements proposed by various scientists from early to modern period. So how the scientists reached certain order from the beginning, from the ancient time. So now we are going to study in the early days how the classification were done. See, early concept of classification of elements. The first classification in 1817 by John Wolfgang Dobereiner. John Wolfgang Dobereiner is a German chemist, suggested a method of grouping elements based on their atomic masses. You have to underline what is the basic principle used Dobereiner, that is atomic mass. So he arranged the element in the order of atomic mass. So he arranged the elements into groups containing 3 elements each. He called this group as triads. So Dobereiner arranged the element 3 by 3. 3 elements in a group, another 3 elements in another group, and yet another group is formed by gathering 3 elements. Such a way grouped element 3 by 3, 3 by 3, 3, that is a tri. 3 means tri in the Greek numeral. So we used to call it as a triads, Dobereiner triads. And see what is that the given in the colored lines are like a definition. When the 3 elements in a triad are arranged in the ascending order of their atomic masses, the atomic masses of the middle element is nearly the same as the average atomic mass of other 2 elements. So he arranged 3 by 3. And what is the peculiarity he found in it? See, the middle element possesses the atomic mass of average of the remaining two. The atomic mass of the middle element is the nearly average of the atomic mass of the other two elements. Such a way he grouped the element, and there is a table 12.1 which shows the Dauber-Inner triads. So in the triad 1, arithmetic mean of atomic mass of first and third element, that is 6.9, 39.1 divided by 2, 23. For example, you take refer the 12.1 triad group 1, the first two column you take. There are three elements are given: lithium, sodium, potassium. These are the three elements. First triad, lithium, sodium, potassium. And lithium atomic mass is 6.9 and potassium atomic mass is 39.1. So according to the Dauber-Inner triad, the average atomic mass of the first and third element will be the nearest atomic mass of the middle element. So we have to take 6.9, 39.1 and add and divided by 2. So 6.9, 39.1, that is 46. 46 divided by 2, 23. So that is the nearest atomic mass of the sodium. Here in this case it is more or less equal to the sodium, but other cases are more or less equal to the middle element. So the atomic mass of sodium is 23. If you take similarly triad group 2, if we take group 2, that is chlorine, bromine, iodine. Chlorine atomic mass 35.5, bromine 79.9, iodine 126.9. So according to Dauber-Inner triad, we have to take the first element, third element, that is chlorine and iodine, 35.5 plus 126.9. So 126.9. So that you are going to get more or less that is 166.4. 166.4 divided by 2, that is going to be 81.2. 81.2, that is nearly equal to bromine atomic mass 79.9. Also you take the another one, that is third group, calcium, strontium, barium. Calcium atomic is 40.1, strontium 87.6, barium 137.3. So we have to take the average of first and third element, that is 40.1 plus 137.3 divided by 2. If you take the sum of 40.1 and 137.3, that is going to be 177.4. 177.4 divided by 2, that is going to be nearly 88.7. 88.7. Here it is given 87. So it is nearly equal to the average atomic mass of the calcium and barium. The strontium atomic mass is nearly equal. So such a way he grouped Dauber-Inner group 3 by 3, but all the elements could not be identified arranged in the form of 3 by 3. That is the limitation. Drawback. Limitation means drawback. Demerits. So what are the drawbacks or demerits of Dauber-Inner triad? Dauber-Inner could identify only 3 triads. See in the tabular column 12.1, only 3 group is given. That is triad group 1, triad group 2, triad. Only 3 groups only he identified. And that time, and all the elements could not be classified. So Dauber-Inner failed to arrange all the elements in the form of 3 by 3, the group of 3 by 3. This is one of the limitation drawback. And second one, the law was not applicable to elements having very low and very high mass. So the elements possessing very low atomic mass, also the element possessing very high atomic masses are would not be classified in the form of triad. would not be classified in the form of triad. This is also another limitation, demerit of the Dauber in a triad. So you have to understand what is Dauber in a triad. Dauber in a arrange the element based on the atomic mass 3 by 3, and in the 3 elements which are called triad, and so when he arranged, the atomic mass of the middle element is nearly same as the average atomic mass of the other 2 elements. Such a way he found only 3 groups. That is the main drawback. The next scientist, Newland law of octaves. Newland law of octaves in 1866, John Newland arranged 56 elements in the increasing order of atomic mass. So he also grouped the element based on the increasing order of atomic mass. So what he observed every 8th element had the property similar to those of the first element, like 8th note in an octave of music similar to the first. This arrangement is called a law of octaves. So he arranged the elements 8 by 8. Dauberiner arranged the element 3 by 3, which is called a Dauberiner triads. But Newland arranged 8 by 8, so it is called a law of octaves. So what is the peculiar property of this arrangement? The 8th element resembles the property of the first element. The 8th element had the property similar to those of the first element. This is resembling the 8th note in an octave of music. 8th note in an octave of music. See, in the Indian music system, that is sa, re, ga, ma, pa, da, ni, sa. So the first note sa, 8th note also sa. So first note, 8th notes are similar to one another. A resemblance is there. Similarly, the properties of the first element, 8th elements are resembling one another in the arrangement of Newland law of octaves. So likewise, in the Newland table of octaves, the element F is the 8th from the element hydrogen. Thus they have similar properties, that fluorine and hydrogen resembling one another in their properties. Also here given, see, the example is given that find a pair of elements having similar properties applying the Newland law of octaves. Example, magnesium and calcium. Magnesium and calcium. Here 2 set is given. You have to go through. Then what is the limitation? There are instances of 2 elements being fitted in the same slab. Sometimes see, 2 elements are going to be fitted in the same place. That is example, cobalt and nickel. Also see, some elements totally dissimilar in their properties are fitted in the same group. So some elements are not fitted. For example, see, when you go into arrange cobalt, nickel, palladium, platinum, iridium, so in the row of halogens, they are not actually fitted in their particular group. So the law of octave was not valid for elements that has atomic mass higher than that of calcium. So atomic mass more than calcium elements cannot be fitted according to the law of octaves. Then Newland law was restricted only 56 elements. It did not leave any room for new elements. So at that time only 56 elements were known. So he arranged only 56 elements. It is not fitted for the new elements which were discovered. Then the discovery of inert gas like helium, neon, argon, krypton, xenon at later stage made the 9th element similar, because these elements are going to be included in the 8th group. So it converted the first and 8th is not possible to similar to one another. The first element resembling the 9th element, the first element resembling the property of 9th element. Such a way the law of octave was dismantled because of the discovery of rare gases, neon between fluorine and sodium. So this is a Newland law of octaves, and you have to understand what is Newland law. John Newland arranged 56 elements increasing order of atomic mass. That is the 8th element had the properties similar to those of the first element, like the 8th note in the octave of music. this is the law, or this is the principle. Sometimes you will be asked, write Newland law of octaves. What is Newland law of octave? Every eighth element had the properties similar to those of the first element, like eighth note in an octave of music is similar to the first. This is called the law of octave. This is called the law of octave. So my dear students, you have to go through and prepare well. Only two laws we have studied. One is a Dauber in a triad and the Newland law of octaves. Dauber in a triad and Newland law of octaves. These two are the early concept of classification of elements. Early concept of classification of element. And the next one is a mentally periodic table that we will study in the next class. You go through what is Dauber in a triad and go through the example, and what is a Newland law of octave, what are the demerits. So don't waste the time, prepare well. Thank you. God bless you.